Hello everyone and welcome back to this lesson on padding and attention masks. So far we looked at how LLMs can tokenize text. We looked at how different tokenizers might decide to break down words into subwords. So now after you converted your text into a list of numbers, now the LLM is ready to process these numbers. So the LLM, as any deep neural network, you pass the inputs as batches, and usually the batch has a certain shape. So we want to construct a matrix where we can pass multiple sentences. So imagine in this example where we want to pass these three sentences, the question would be, what should the shape of the matrix be? So here we have three samples, which means we should have three rows, one row for each sample. And the number of columns should be equal to the number of tokens in each sample. But then the question is, the samples actually have different number of tokens. So how are we going to construct the matrix? Turns out, here comes padding, which is we unify the number of tokens in all of the samples to match the longest one. So in this case, this sentence is the longest, contains the most amount of tokens. So what we need to do is we pad the other sentences by inserting a special token. It's called a padding token. It's inserted just to make the shape of the matrix valid in order to put these three sentences in a matrix together. And then comes what's called the attention mask, which is another matrix of zeros and ones, where you put a 1 whenever this token is a real token, it's a valid token, and you replace the padding tokens by 0. And this is used in order to tell the LLM whether this token was real or if it was just a padding token that was inserted just to make the shape of the matrix valid. So this is the idea of padding and attention masks. And yeah, let's take a look at it in code and see how it's done. So we'll start by loading in the llama model. Let's take a look at some of the special tokens that it has. So here it has the beginning of sentence, which is this ID, the end of sentence, which is this one, and it doesn't have a padding token. So whenever your tokenizer does not have a padding token, because not all tokenizers define this, by convention, you should define your padding token to be equal to the EOS token. So in this case, the EOS token ID would be used for two different things. It would be used to define the end of the sentence, and any padding token should also take in the same ID. So let's take a look at these sentences here. So we have 4 different sentences varying in lengths. So imagine we want to pass this to an LLM. So we want to construct a matrix of these sentences. So if you scroll down here, let's tokenize them. So we call in the tokenizer, the encode method, and then this is what it returns. So every sentence is tokenized, and notice that this is the BOS token always inserted at the beginning of a sentence. If you are asking why the EOS token is not at the end, this is because these are the input IDs. These are the features that we pass to the LLM, whereas the labels, they are the ones that include the EOS token. So we will get to that later when we talk about how the labels are constructed. But for now, you will only see EOS tokens in labels. Usually they are not present in the features themselves. So now we start setting in the padding token. So again, some tokenizers will have it, some tokenizers won't. So in this case, we are having an if condition. If the padding token does not exist, we manually set it to be equal to the end of sequence token. And then we start tokenizing these sentences. So this is the first time that we call the tokenizer itself. We are not calling the encode method. So you can directly call the tokenizer. You pass in the sentences and you pass the padding option to true. So you want the tokenizer to do the padding. There is also a truncation option where you can, for example, explicitly tell the tokenizer to return a maximum length, for example, that if a sentence goes beyond like 20 tokens, for example, just return the first 20 tokens. So we're not doing this here. We are returning PyTorch tensors, and we want to return the attention mask, and we will take a look at these things. So you get a result object, which is a dictionary. and it has multiple keys. One of them is the input IDs, which is the actual tokens of the sentences, and the other one is the attention mask. So let's take a look at it. So the shape of the input IDs, if you examine the input IDs, it's 4 by 12. Where did this come from? Well, we have 4 sentences, so the matrix has 4 rows, and the largest one of them was 12 tokens. So that's why it's 4 by 12. So let's take a look at how these sentences look like. So here is the high. You can see previously it was 3 tokens, which is the BOS, and then the high, and then the exclamation mark. And then we have to pad this sentence in order to match the longest one, which is this one. So the longest one was 12. Now we have 3 tokens. This means we have to insert an extra 9 tokens in order to match the longest one. And here, this is the padding token, which we manually set to be equal to the EOS token. So this is how the sentence high would look like, just because it was processed in a batch that has a very large sentence. Maybe if it was processed with another batch that has smaller sentences, you wouldn't need to insert all of these padding tokens. And so on for all the other sentences. You'll see you always have the real tokens, and then you insert some padding tokens just to match the length of the largest sentence. So now let's take a look at the attention mask. So this is the high token. Again, it had 3 different tokens, including the BOS one. We always include it. So that's why the attention mask for this is going to be 3 ones, because it has 3 tokens and then zeros. So when the LLM sees this, it knows that there's only 3 real tokens, and these ones it would not pay attention to when it's doing the computation, and so on for different tokens. So real tokens, padding tokens, and for the last one, this is the longest sentence, so actually all of its tokens are real. This is the only one that did not get padded at all. And then you can look at the complete matrices. So this is how the LLM would process the 4 sentences as a batch. So this is a PyTorch tensor. It's a 2D one, 4 by 12, and this is the attention mask of this tensor. So that's it for this video. We quickly covered padding and attention masks. This is going to be very important for fine-tuning because you will run across these things a lot. You will run across the 2 keys input IDs and attention masks a lot whenever you're working with Hugging Face. So this is what it actually means. I hope you found that useful, and I'll see you in the next video.